Okay. Hi. Welcome for this virtual lab practical. So, as already we have covered theoretical part for the DC generator. So, as we have seen that DC generator, which is having internal as well as external characteristics. So, today we are going to understand the practical regarding how this external as well as internal characteristics looks on the graphs. So before that, we will perform that virtually, and after that, we will discuss on the graphs. So let me share my screen. Yeah, so I hope it is visible to you all. So as we need to first go for the virtual lab website. So on Google, you can simply search that VLab. So there will be a first option that will be the vlab.co.in, right? So you can simply click on that. Okay. So once you will open this, at that time there are broad areas of the virtual labs, and in this section you can find electrical engineering. Okay, so here you can find this electrical engineering. So you have to simply click on that. So it will redirect you to the electrical engineering, whatever be the virtual lab practicals are there. So you can see here that virtual lab high voltage for the power, for the electrical drives, for the machine. So again, that again for the institutions like IIT Bombay, COEP Pune, IIT Kharagpur, IIT Roorkee, they have developed virtual labs. So here we'll go with the electrical machines lab, which is recently developed by the IIT Roorkee, right? So we'll click on this that electrical machines lab, and will it will redirect to us to the new page. And here you can see this is for the electrical machine simulation. And as already in first lecture, first practical that was regarding the familiarization of the various electrical equipments that are used for the practical purpose. So we have discussed that time what were the objects. Still, we'll just revise. So important object of these electrical machines virtual lab is to learn and understand the basic concepts regarding the electrical machines. So that machines includes DC motors, DC generators, then AC induction motors, okay, synchronous motor and alternators. So also a transformer is also part of this electrical machine. So here uh, we'll go for the list, and already as I told you that first practical we have studied already, right? So today we are moving towards the next practical that is about the to study the load characteristics of DC shunt generator, right? So just will focus on this. And as I told you that whatever be the load characters are there, that is nothing but what internal as well as external. So let us go for the practical, and here you can see the aim of the practical, that is to study the load characteristics of DC generator, and draw the internal characteristics and external characteristics under the different loading condition. So whenever we are going to study the load characteristics of DC generator, that time we have to apply various loads. So how it is going to apply virtually, that also I'll discuss in the next few 5 to 10 minutes. So before going for the main aim of our practical, that regarding the load characteristics, we'll just go through the little bit theory about this point. So here you can see the figure, that is equivalent circuit of the shunt wound generator. So here, in as we know that the field winding here, this is the field winding, right? So this field winding is connected in parallel with the armature winding. So whatever be the terminal voltage, that is V, that as these both are connected parallel, so that whole whatever be voltage appearing across this load, that is again appear across the armature winding as well as shunt winding. So whatever be the shunt winding is there, that is having a number of turns, and that turns includes very high resistances. So due to that, a single thing we need to understand, whatever be the armature current that is flowing through these armature winding, that will also flow through the shunt winding, but the amount of this current will be less due to the high resistance. So as we know that in this case, if suppose at this place we will apply the KCL, then we will understand IA is equal to our ISH plus IL, right? Yeah, sorry, some little internet connectivity issue was there. No issue. Now we'll understand, as I was discussing about the whatever be a KCL we will apply here, so that will give us a equation for the current that will be IA is equal to load current plus whatever be the shunt field current, right? So that armature current will be equal to So let us go back to the virtual lab. Okay, so let us go back to the virtual lab and you can see the post test is there. So all are requested that from this experiment, you should go through this test and send me the screenshot in our WhatsApp group. So I'll get the idea how much the knowledge we have shared right now, how much you have grasped that. So all are requested that 5 question quiz for you. Immediately, you should just go to the V Lab and select for the IIT Roorkee Machine Lab, Virtual Lab, and go for the first experiments post test. Okay, so for this, we'll stop here today. If any questions, you can ask. Otherwise, we'll close. Okay, fine. So we'll stop.